All right, hello. Today we are going to be working on lesson 2.2b. So if you could, please, on the front of your packet, write your goal for 2.2b. Today you will be able to find the probability of an event with a combination and FCP. So in this section, things that we have been talking about so far in chapter 2, we're going to see probability. We're going to be writing our answers as fractions and decimals and percentages. Also, we can see combinations that are coming back. So that will be coming back from chapter 1. We're going to be having combinations of and combinations of or. So all that knowledge from chapter 1 is going to come back today. So first thing we're going to talk about is the Powerball. This is something a lot of us adults play to quick scheme to get money. It's a very interesting probability equation and problem. All right, so how it works. So at the beginning in October of 2015, the Powerball became even larger combined with a large jackpot game and cash game. Every Wednesday and Saturday night at 10:59 p.m. Eastern Time, we draw 5 white balls. Underline that seems important. Out of a drum of 69 balls, and 1 red ball out of a drum with 26 red balls. This change means there are bigger jackpots. It also means the odds of winning a prize improved. So we can see here that we have a combination, because it doesn't matter how the white balls are chosen or the red balls, and then also we have the word and. So reminder from chapter 1, the and means we're going to multiply. Okay. So what we're going to do is we're going to find the probability of us winning. Okay. Reminder, probability on top, you put what we want, and on the bottom we have to put the total. So that's the first thing we need to find, is we need to find out what's the total. What are all the different combinations of ways that these balls could get drawn on that Wednesday and that Saturday? Okay, so let's first talk about the white ones, the white balls. So we know all together there are 69 balls, and we know that we are going to be selecting 5 of them. We have that word and, so we know we're multiplying. Okay. And then we have the red balls, so there are 26 of them, and we are only selecting 1 of them. So a reminder, when you are doing combinations, this is something you will want to have a calculator for today. Okay. So when we plug this in, and I figure out the first combination, and I multiply it to the second combination, what we find out when we plug that into our calculator, there are 292,201,338 ways that all of these different numbers and balls can be selected. Okay? So obviously, if you're playing the Powerball, you want to win. So we're finding the probability of winning. Okay? And if you want to be the winner, if you want to be the one person that wins, so you can be 1 out of, and then as I said, this is our total. This is the total number of ways that we just found. So that number is going to go on the bottom. So as you can see, there's not a great probability of winning. Okay, 1 out of 292 million. And so let's see if we did this right. So here is there are 5 white balls, 1 red ball. Grand prize is 1 in our number that we found, so we know we did that correctly. Okay. All right, let's flip our page. We want to get things right on our test, so guessing on the test. So this time, you have 9 questions, and there are 5 answer choices. 15 of the questions with 4 answer choices. What is the probability that you ace this test if you randomly filled in the answer sheet? So right now, 9 of the questions have 5 answers. So what that would look like is I would have 9 blanks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And each one of these would have 5 answers. So I have 5, 5, 5, 5, 5, 5, 5, 5, 5. Now, I don't know about you, but I don't feel like that's the best and fastest way. So what we would really do here is I would take all these and I would multiply them. And so what it really is, it's 5 to the 9th power. Okay? So let's say you just do this first part. Now again, do you want to make 15 blanks? I don't know about you guys, but I don't want to do that. So this next one, and notice we have the word and, so I have times. So this next one, we have 4 answers for 15 questions. Okay? So now, when we plug that into our calculator, now let's think about this. You're taking 5 times 5, 9 times, and then you're multiplying that to 4 times 4, 15 times. So when you plug that into your calculator is like, hey, this number is way too large. So when it gives this to you, it's going to give it to you in scientific notation. And we are going to have 2.09 times 10 to the 15th. So those are all the different ways we could fill in our test if you just randomly filled it in. Okay. Now, how many correct answer keys are there? Well, for each problem, there's only one answer that's correct. Okay. That's the one nice thing about math, that there's one right answer and then several wrong answers. Okay. So then, if I'm trying to figure out, sorry guys, if I'm trying to figure out all correct, well, there is one correct answer for each of these, and total, these are all of the ways that you could fill in your test. So the probability on that is not great. That's why we do not want you to randomly fill those out. We would like it if you would study and actually get those correct. Okay? All right. Our next problem is talking about probability. Again, a reminder, you put number of successes over total number of outcomes. This is what we're going to be using today to help us solve. So it says we have a 5-card hand from a standard 52-card deck. Okay. And the first thing we want to find is we want to find the probability of 5 face cards. Okay. So because of that, I'm going to use P for probability. I'm going to do 5 face, and we'll just say face. We won't write cards because we know we're using cards. Okay. So we know we have a combination. Remember that from chapter 1, because it doesn't matter how we're handed them. It matters that they're in our hand. So on top, we have to talk about what we want. We want face cards. So reminder, in a deck, in each suit, there are 3 face cards. So if there's 4 suits, 3 face cards, all together in a deck, there are 12 face cards. But we want 5 of them, so we're going to put 5 here. And the reminder on the bottom, you put the total. Well, we know in a card deck there are 52 cards, and we are selecting 5 of them. Okay. So again, we're going to plug this into our calculator. So on top, when we plug our combination, on top, we know we're going to get 792. And on bottom, I feel like we found this number a whole bunch. We're going to get 2,598,960. I'm going to have you take this one step further. We are going to write this as a decimal. So reminder, you're going to take in your calculator, you'll take 792, and you'll divide it by this 2,598,960. And when we do that, now remember we have talked about significant digits, so we're going to get 0.000305. So as we can see there, it's very far away from 1, so you do not have a good probability of getting all 5 face cards right away. All right. Our next question. It says, what is the probability of getting exactly 3 aces? Okay. So again, I'm going to say probability. We're trying to get 3 aces. So a reminder at the very beginning though, we are getting 5 cards. So keep that in mind as we're answering this. So already on the bottom, I know that's not changing. I have 52 cards and I'm selecting 5 cards. Okay. Well, let's go back to this. Exactly 3 aces. So in a deck, I know there are 4 aces, but I'm only selecting 3 of them. Okay. Now I know I still need 2 more cards because I have a hand of 5. Okay. Reminder this really important word. It says exactly 3 aces. So the other card can't be an ace. I can't have any more aces. So that means this number here is going to change. Okay? So what it means is I'm going to take my 52 cards and I'm going to take out all the aces. So remember there are 4 aces. So I'm taking them out of my 52. So there are going to be 48 cards left. Okay? So again, you're going to plug these 2 into your calculator. We're going to multiply those 2. And when we do that, we are going to get 4,512. And then on the bottom, that didn't change. We still have that 2,598,916. Again, I'm going to have you take this one step further. We're going to divide those and we're going to turn it into a decimal. We have a probability of 0.00174. So again, that's far away from 1. It's a little bit closer than our first problem, but still not a great probability of getting exactly 3 aces. Okay. All right. We are going to do the same thing here. All right, so again, we want to get exactly, and again, reminder at the very beginning, I'm just going to write this to ourselves, that we're doing a 5-card hand. So we know all together we're trying to get 5 cards. All right, so it says here that we want to get exactly 2 clubs, exactly 2 clubs. So keep in mind, again, on the bottom, that's not changing, it's going to be 52C5, that's not changing. Now on the top, reminder, clubs, each deck has 13 clubs. So I'm going to say 13, pick 2. And remember it says exactly, so now I need to take the deck of 52 and take out those 13. So when I take 52 minus 13, the rest of the hand, the rest of the deck has 39 cards that are not clubs. Because remember, I still need to have 3 cards, because remember, we are trying to total up to 5 cards together. So now, when we multiply the top, we figure out the bottom. The top has a total of 712,842. That's a 2 there, sorry guys. And then on the bottom, this isn't changing. This is nice. You guys are going to start remembering this number. Again, I'm going to have you guys take this one step further. I'm going to have you guys divide that. And when we do that, and I'm going to have you guys, we're going to write this as a decimal for this one. It's going to be a nice one. So we're going to have 0.277, and we are going to turn that into 27.7%. So you have a better probability of having exactly 2 clubs in your hands versus the other 2 problems with the exactly 3 aces or 5 ace cards. Let's look at the difference of 1 club. Okay, so this time it's going to be very similar to this one that we just found, but instead on top, again I have 13 clubs, but this time I only want 1. Okay, on top again we have to take out all of the clubs. So I'm going to take 52 minus 13. I'm going to get 39. Now this time, because only one card was chosen, I still need to pick 4 more cards. And then on the bottom here, we have our total. So remember, we have a total of the 52 over 5. So now again, we're going to figure out the top. I'm going to have to erase this because I'm running out of space. On top, when we multiply this, we're going to get 1,065,263. And on bottom, what we're going to have is again your 2,598,960. Now this time, when we divide this, we're going to have a better probability. When we divide these, we're going to get 0.411, which is the same as 41.1%. So we have a better probability of getting exactly 1 club. Now let's talk about this last one. I'm going to have to do a little erasing. So we're going to talk about the fact that we want no clubs, absolutely no clubs. So on the top, if we think about it, we are going to take out this first combination because I don't want any clubs. So here we go. I hope you guys have this written down. I'm going to erase. So this time, we are going to take out all of those clubs. So if I take out all the clubs, what I have left is I have 39 cards. And we want to pick all 5 of our cards from those 39 cards because I don't want clubs. On the bottom here, we still have our total. Oops, sorry, we have 52. I was going to go straight to the 2 million. We have our 52 C over 5, or C5. So then again, we're going to figure out the top. We're going to figure out the bottom. So when we plug this into our calculator, we are going to get 575,757. And this is going to be all over our 2,198,960. Now again, when we divide these, I'm going to get 0.222%, or I'm sorry, 0.22222, which is going to become 22.2%. So as you can see here, the best probability that you have, if I compare these 3 answers, is this one right here. That one has the best probability of getting exactly 1 club. All right, let's talk about an OR problem. So this one says, what is the probability of at most 2 clubs? So let's talk about that. So that means at most 2 clubs. I don't want to go above 2 clubs. So what it means is I'm going to take 0 clubs, or 1 club, or 2 clubs. Well, we already found that, guys, right? We just found that up above here. So we found out when we found 0 clubs, we were at 22.2%. When we found 1 club, we were at 41.1%. And when we were at 2 clubs, we were at 27.4%. And again, because this is an OR problem, we are going to take these and we are going to add them. So when we add these 3 percentages, what we're going to get is we're going to get 90.7%. So there's a really good probability, because that's really close to 100%, of getting at most 2 clubs. And again, those are words and phrases that we talked about in chapter 1, so that should be. All right, we're going to do a quick, another problem about a classroom. All right, no more card problems, you guys are welcome. All right, this last problem that we're going to talk about, and I'm actually going to take out a couple just to kind of help us on time. It says you have a class of 35 students, 20 of them are girls, and your teacher is forming groups of 5 for a project. Let's talk real quick. We know if 35 of the students in your class, but 20 of them are girls, let's pause real quick. that means there have to be 15 boys. Because we know 20 plus 15 is going to give us that 35. All right. So it says, and how many different groups of 5 can be formed? So again, reminder, this is a combination. It doesn't matter the order in which we pick. So let's just talk about the fact this is talking about our total. So this is what's going to be on the bottom of all of our probability fractions. Okay? So we have a combination, and it says group. So it's saying how many people. So it doesn't really matter if they're boy or girl. So we have 35 people, and we're picking 5. So again, when we plug this into our calculator, we're going to get 324,632. So this number, we're going to be using it on the bottom as our total in a lot of our problems. So our first equation, or our first probability is talking about 5 boys. So I would say P, 5 boys that we're selecting. So on top, we have to have our success. So we know in our class, I have 15 boys. I'm picking 5. And then on the bottom, again, remember you put your total. To help us with time, I'm going to pause it there. The next one, I'm finding probability of 4 boys. Well, let's pause for a second. If I have 4 boys that I'm doing groups of 5, I know if I have 4 boys, that means there has to be 1 girl in there. Okay? So on top, that means I'm picking from my 15 boys, I'm picking 4 of them. But I also need to pick from the girls. I need to pick 1 of them. So reminder, there are 20 girls. And again, reminder, the bottom is not changing. That's going to be 35. Pick 5. And again, guys, just for time-wise, I'm going to not plug this into our calculator. On your homework, I will need you to plug this into your calculator. But right now, I'm trying to give you guys some more time right now. All right. Our next problem, this time I want to have 3 boys. So again, keep in mind, if I have 3 boys, that means I have to have 2 girls. So on top, I have 15 boys. I'm picking 3. That means I have 20 girls. And I'm picking 2 of them. And reminder on the bottom, we're putting our grand total. Next one, we're going to do 2 boys. 2 boys. So I have 15, pick 2. So that means now I need to have 3 girls. We have our total. So right now we're seeing the boys. We're getting less and less boys in our groups. And more girls. Our last 2 here. I'm picking 1 boy. So that means I have 15 boys. I'm picking 1. And that means I have to have 4 girls. And our very last one here, I have 0 boys. So that means I'd have 15, pick 0. And that means all the girls are being chosen for this group. this is how you're going to be setting up your problems today. We're combining what we did from Chapter 1 with stuff from Chapter 2. So combinations are coming back, and you're going to apply it to our probability knowledge. Your homework is going to be 2.2b. Use these skills on there, and have a great day.